To get our enemies into our levels and the game, we are now back in our game scene SKS file. In the file for our first level, I can now, just like I added my blocks, also add an enemy to my scene. So let's use this image for the placeholder and drag it onto my map. We can see that it is currently way too big for our game. But I can easily fix this by changing the scale property in the inspector to maybe 0.4. Or maybe even a little smaller, so 0.3 for both X and Y. Now this looks much better. I can then position my enemy where I want him to be, so maybe on this glass block in the middle here. And as it is now, this should not really work. And we could not find a node in our game scene class. So we do need to make sure that our enemy is a child node of the tilemap node by dragging it in like so. I will also have to specify its name. Just like we did call our blocks stone, wood and glass, so by their type, I will now call this enemy node orange, which is its type. And that's all for the SKS file. So let's go back to the Swift file, gamescene.swift, where I will now think about where to add our enemy nodes. But before we add them, let's just think about what we need to do differently for our enemies. Contrary to the blocks, we do have to somehow keep track of the enemies in our scene, since the ultimate goal of the game will be to destroy all enemies in each level. So we must have some way of knowing how many enemies are still left at all times. That's why I will add a new property to my game scene class, which will be added below the birds property. It will be a variable called enemies, which I will initially set to 0. I will then also add a didSetObserver to this property, which will allow me to check the current value of the property each time it's changed. Inside of this observer, I want to check if enemies is less than 1, meaning we would have no enemies left in the scene. And then for now, I just want to print all enemies hit to be able to verify the system we are going to implement works. Now that I have this in place, let's scroll to the setup level method, where we already are adding our blocks. If you remember correctly, we have this for loop iterating over all the map node's children. We then check if the child node is a SK sprite node. Just like the blocks, our enemy placeholder is an SK sprite node, so we will get them in this loop as well. It does have a different name though, not wood, stone, nor glass. I can then just use this existing for loop to also add our enemies, and all we need to do is just modify it a little. This guard statement to get the name of the node will also be needed for our enemies, since we need to use this name to initialize the enemy then. But after this line, I now want to change this by adding a switch statement that should check the name we just initialized. For the first case, I will just check what we as of now checked in the if statement below, by testing if the name is wood, stone or glass, in which case we would need to add a block node. I'll add a break statement for now and then add the second case, which as of now only checks for the value orange, in which case we would of course have to add an enemy. I'll also add a break here and then add the default case with a break statement as well. But what do we do here? If we get a name for the child node, we check whether this name is either wood, stone or glass, so a block node, or if it is orange, so an enemy node. In these cases, I can then add the appropriate code to add the nodes. The default case is needed here in case we have sprite nodes that we don't want to replace, so we just add the break. I can then delete this if statement here, since we don't need it anymore with the switch solution that we came up with. Then I want to take this whole part here, beginning with the guard statement and the creation of the block, and wrap it in its own custom method. So I'll just cut it here, and then I will scroll down a little where I will create a method with the name createBlock. It will get a parameter called from placeholder of the type skSpriteNode and a parameter name of type string. I also want this method to return a block node for us that we can then add to our scene. Inside of the method, I will just paste the code I cut from setup level, but I will have to modify it a little. In the guard statement for the block instance, I will of course not write continue, since we are not in a for loop anymore. Instead, I will just write return nil, since in this case we will of course not get an actual block node initialized that we could return. For this to work, I will have to make my return value of the method optional. So let's add a question mark after the block here. Okay, let's go over the method real quickly. We start by hopefully initializing a block type in the type constant right here. If we succeeded, we initialize a block node with this type. This node will then be adjusted to the values of our placeholder node, which I will here, of course, have to reference with the placeholder parameter instead of child. So let's change that. Finally, the physics body gets added to my block node, so that I can, at the very bottom of the method, now add return block to return this block node. In the setup level method in my for loop, I can then use this by first deleting these two lines that are still there. And I now want to, for the case wood, stone or glass in the switch, call my new method. Since it only returns an optional block though, I will use an if-let statement by writing if-let block is createBlock with the parameters child and name. So we pass the current child node and its name to the method that should then hopefully return a block node for us. If this succeeds, I can again use mapNode.addChild to add the block and remove the placeholder with child.remove from parent. All this doesn't do anything different than what happened before, but we did clean up our code with the custom createBlock method that makes our setup level method here way less cluttered and much more readable. We can then also use this procedure to create our enemies. Therefore, we will scroll down to the createBlock method, where we now will also add a createEnemy method. It will get the exact same parameters with placeholder and name, but in this case, I want to return an optional enemy node, of course. How do we create our enemy now? Well, in the beginning, it is pretty similar to the block, and we can just start by writing guard letEnemyType is a new enemy type instance initialized with the raw value name. If this doesn't work, we will just return nil, just like for the blocks above. If we do get a valid type, I can create a new constant, enemy, as an enemy instance initialized with the enemy type. I then have to adjust my new node to the same properties as the placeholder, beginning with enemy.size, which will be placeholder.size, and then enemy.position, which will be placeholder.position. For the blocks, we have then also set the rotation, but since our enemies are always in the same rotation, we don't have to set this here. We do, however, also want to create the physics body, so let's add enemy.createPhysicsBody and finally use return enemy to return my newly created enemy node. I can then scroll back up to the switch statement, where we will now implement the case orange by writing if let enemy is create enemy with child and name. And if we get this, I will add this enemy to the map node as a child, and again use child.remove from parent to remove the placeholder. For this case, I will yet add another line right after adding the enemy node to the map node by writing enemies plus equals 1. This will keep our enemies property updated correctly, so that we always add 1 if we actually add an enemy to our game in the setup. We could run the app now, and we would already see our enemy being added correctly to the scene. But before we do that, we should also implement the logic for contacts between our bird and the enemy, so that we handle this properly as well. To do that, I will jump to the extension containing the didBeginContact method from the physicsContact delegate, where I want to add another case for the contact between our bird and an enemy. So right at the bottom, I will add another case, which will be physicsCategory.bird, bitwise or physicsCategory.enemy. How do we implement this? For our bird node, we don't want to change anything, since in this game, the enemies can't hurt us, we only hurt them. Therefore, we will need to find out which node is the enemy in this contact. We can use our good old if-let structure to do so by writing if-let enemy is contact.bodya.node as enemy, and also else if let enemy is contact.bodyb.node as enemy. And in both these cases, I will now have to impact our enemy just like we did with our blocks. There is a slight difference though. If you think back to how we implemented the impact method for the enemy class, we did add a return value to it, indicating whether or not the enemy was destroyed. We can now make use of this by back in our game scene, writing if enemy.impact, where we just, as before, pass the collision impulse of the contact, cast it as an integer as the parameter. But I will now additionally get the information whether or not our enemy is dead, which would be the case in this if statement. So I'm going to do enemies minus equals 1 to remove one enemy from the level. Exactly the same should be done in this other part. So I'll just copy this over here. All the way at the top, we have added the didSetUpServer to this property that for the case that all enemies are gone, prints this to our console. We also want to know when we fail the level. So we don't have any birds left, but there are still more than one enemy left. And therefore, we'll just go back to the addBird method, where I will right at the top change this print statement to say game over. Alright, we've once again implemented a lot of stuff and even changed our code from earlier in the course to be more clear and better structured. This also makes adding elements to our scene really flexible with this switch, since we can now easily add different enemy types, different block types, and maybe even completely new elements to the scene. But it's now time to run the app again and see if all of this works. We should be able to see our animated enemy, and hopefully we'll be able to impact him and ultimately remove him from the scene. I'll select my level 1, where I can then see my animated enemy if I zoom out a little. I will now try to hit him with my birds and see if we can defeat him. So let's also shoot him with the bluebird, and voila, the enemy disappeared and we have successfully defeated him. If I now stop the app and take a look at my console, we should hopefully see the output that we have hit all enemies. If this system with the bool return from the impact method worked, at least, And as we can see, the print statement is here, that all enemies were hit. So all of this works perfect. It would be better to not only have this print statement here though, but still remain in our game, or at least in a state in our game where we are unable to advance, but maybe get a little pop-up where we can select stuff such as retrying this level, advancing to the next level, or going back to the menu.